All right, so we're finally starting chapter 8. 8.1 is on graphing and writing linear functions. So every linear equation, except for a vertical line, and there's a typo here, this should be x equals c, are functions. So you've talked about functions in other classes. You know, one way to see if a graph is a function is by doing the vertical line test, and every line will pass the vertical line test except for a vertical line. So that's why the only lines that are not functions are vertical. Okay, so we are going to graph these. So you learned a lot of different ways to graph lines, and one of the ways you learn to graph a line is to simply make an XY chart. And in this case, it's not a y. This is in function notation. So it's in an x, g of x. So let me just quickly review. Remember what you do here? You pick any values you want for x. I'm going to pick those 3. And you plug them in to find in this case, g of x. So if I plug in -1 into here, -2 times -1 is 2 plus 5 is 7. And that gives me an ordered pair that lies on my line. If I plug in a 0, you should see you're going to get 5. If I plug in a 1, you can see you're going to get 3. 3 points are the minimum number of points that you should always have to graph a line. Now let's see if those 3 points line up when we graph them. -1, 7 is up there. 0, 1, 2, 3, 4, 5 is up here. And then 1, 3 is up here. You can see that they line up beautifully. Oops, I kind of missed. So when you go graph your line, make sure, please, that you put arrows on both ends because it is a line you're graphing. It goes on and on forever in both directions. It's an infinite set of points. Okay, so the book calls this the general form of a linear function. You may also recognize this as slope-intercept form for Math 53, where M stands for the slope and B stands for the y-intercept, or where the line crosses the y-axis. So if we were to graph this line, which is in that general form, and by the way, I know the first example was also in general form, but we just graphed it using a point. You can always graph by finding points. But another way, quicker way to graph a line, if you are using this general form, is go to the y-intercept first. So it means it's going to cross the y-axis down at -2. Now your slope is 3 over 1. Remember the words rise over run from Math 53? So from your y-intercept, you're going to rise up 1, 2, 3. And then you're going to run +1, which means to the right 1. And if you want to repeat that, 1, 2, 3, whoops, yep, and up 1. You don't have to repeat it, but some people like to. There is a visual or a picture of that line. So there's a quick review on graphing lines. So now, another form of the line, which happens to be, by the way, my favorite form of the line, is point-slope form. And here is what point-slope form looks like. The M stands for the slope, as you can see is typed out. And the x1 comma y1 is a point that lies on a line. So for example, if I had y minus 5 equals 2 times x plus 6, there's a line in point slope form. You can see that the slope is going to be 2. Now, a point that lies on this line is going to be -6, 5. This is really x minus -6. Since the form is x minus, you always take the opposite of that. That's why this is a -6 and this is a +5. Okay, so remember that. So as we go through, if you look at our next example, we're going to write the equation of the line that passes through these 2 points. Now, there are 2 things that you have to know to write the equation of a line: the slope and 1 point. So, one thing I don't know here is the slope, so I need to remind you of your slope formula. All of this should look familiar to you. The slope formula is the difference in the y's over the difference in the x's. So this point is x1, y1, and this point is x2, y2. So let's go ahead and let's plug in those values to be able to find the slope. So y2 minus y1 over x2 minus x1. Well, -3 minus 0 is -3, and -4 minus 2 is -6. Make sure you reduce. The slope of my line is 1/2. So now what I'm going to do is I'm going to go to my point slope form, and I'm going to plug in either point. By the way, it doesn't matter. I'm just going to use this one because I like the 0. I'm going to plug this point in for x1, y1, and I'm going to plug in my slope. So it would be y minus y1 would be y minus 0 equals the slope times x minus x1. Well, if I clean it up, this is just going to be y equals, distribute through, I'm going to have 1/2 x minus 1/2 times 2 is 1. And there's the equation of a line. And it happens to be in that point slope form, or in that slope intercept form. All right, let's take a quick look at vertical and horizontal lines. So a horizontal line is a line of the form y equals b. It is a y equals. So an example of a horizontal line might be y equals -3. Now, if you forget which one is horizontal and which one is vertical, let me show you how you can remember. What does this equation say? This equation says y equals -3. No matter what, y equals -3. So what if I just threw some -3's down here? Because it says y equals -3. And I can pop anything in I want for x. If I were to graph those 3 points, I would get 0, -3, 1, -3, 2, -3, and voila. You can see that that is a vertical line. Or, I'm sorry, that is a horizontal line. Check that. Which is a function, by the way, because it passes the vertical line test. A vertical line, which is not a function we talked about, is a line of the form x equals c. So for example, x equals, 4. If you've forgotten that that's a vertical line, you can do the same type of thing. This says that x equals 4. No matter what, x is always 4. Plug anything you want in for y, and if you were to plot those points, you could see you would get 1, 2, 3, 4, 0, 4, 1, 4, 2. You can see that that is a vertical line that goes through the x-axis at 4. So there's a quick review of vertical and horizontal lines. Let's talk about parallel lines here. So remember, parallel lines are lines that never meet. What you need to remember is that parallel lines have the same slope. So if they're parallel, the slope of the first one is going to equal the slope of the second one, because they rise or fall at the exact same rate. And that's really all slope is it's a rate. So let's look at this example. Write the equation of the line that's parallel to this line and passes through this point. So here's our x1, y1. Now remember, the two things that you have to know to come up with the equation of a line are a point and the slope. So let's talk about the slope. Since the equation of the line that I'm coming up with, that line is parallel to this line, it means it has the same slope. There are a couple of ways you could find the slope of this line. One way would be to take this line and put it into slope-intercept form. If I take this line and I put it into slope-intercept form, that means I want to get the y alone on one side. So the first thing I would do is subtract the 2x, and I would divide by 5. So here's the line in slope-intercept form. Here is the slope. So since this is the slope of this line, and my line is parallel to it, it is also the slope of the line that I am trying to come up with. So I'm just going to make a note that the slope is going to be negative 2/5. Now, let me show you a little shortcut. If you are given a line in this form, 2x plus 5y equals negative 6. Back in 53, you called this standard form. So this is ax plus by equals c. That's what standard form was. Another way to find your slope is to take negative a over b. Always works. So if you look at this, I would take negative a, so that would be negative 2 over b. And you can see the slope is negative 2/5. So either way, whatever you're comfortable with. Okay, so now we're back up to where we were at the example at the top. We have a point, we have the slope, so we're going to go ahead and we're going to write the equation of our line in point slope form. So it's y minus negative 3 is equal to the slope times x minus 2. Well, minus a negative is really plus. So now let's go ahead and let's put this in that what they call general form, which you and I both know is slope-intercept form. So we'll distribute. So that's going to be negative 2/5 x plus, if I distribute this here, I'm going to get 4/5. Remember, this is really over 1. And now I'm going to have to subtract the 3, which means I'm going to have to subtract 3 over there. So y is going to be equal to negative 2/5 x. Okay, now you can use your calculator. I'm just going to use my head. So if I want to subtract 3, I need a common denominator between these two. My common denominator is 5. So top and bottom have to be multiplied by 5, and 3 times 5 is 15. So it's 4/5 minus 15/5, which is negative 11/5. And there we go. All right, we're on to perpendicular lines. So if you remember, perpendicular lines are two lines whose slopes are opposite reciprocals of one another. So if you have the slope of one line, and if they're perpendicular, it means their slopes are opposite reciprocals. So you change the sign and you take the reciprocal. So for example, if we just go up here, if I tell you that the slope of a line is 2/5, the slope of the line that's perpendicular to it would be negative 5/2. If I tell you the slope of a line is negative 6, the slope of the line perpendicular to that would be positive 1/6. So opposite reciprocals. So here we go again. Our process is going to be very similar to what we just did, except for what we do with the slopes. So we have our point. That's my x1, y1. Let's find the slope of this line. Well, notice it's in standard form where my a is 1. So remember, the easiest way to find the slope is to do negative a over b, which in this case is negative 1 over 5. Now, that is the slope of this line right here. We are trying to write the equation of a line that is perpendicular to that. So that means that the slope of my line would be positive 5. It's the opposite reciprocal of negative 1/5. So here we go. Let's go to that point slope form. So again, it would be y minus negative 3 is equal to the slope times x minus 8. So y plus 3 equals 5x minus 40 if you distribute. And finally, y is going to be equal to, because we have to subtract 3, 5x minus 43. And there you go. And that's the end of 8.1.